Pre-calculus students, welcome to your 9.6 notes. Today we're going to go a little further into this whole polar equations thing and polar graphing. So hopefully together we can help each other polarize a little bit. So anyway, we'll try to get rid of those problems too. So here we go. Let's take a look at some interesting graphs that we run into with polar graphing. You can see them on your first slide and on your screen right now as well. The limacone, we have actually three of them, and the cardioid is kind of a variation of that limacone, excuse me. The limacone with the inner loop, the dimpled limacone, and then the convex limacone. This almost looks like a circle, but if you look closely, that left side is a little bit flattened. And then the cardioid, you can see there's a big difference in the cardioid and the dimpled limacone, and that this is actually a point that has a sharp turn, where this is actually a smooth curve. Also, this goes back to, well, what we used to call the origin. We're going to start referencing this as the pole, since we're working in polar graphing now. But in any case, you'll see those differences pretty easily, I believe. The next two, we have rose curves, and I'm showing you examples with 3 petals and 8, but there are more than that. You just count the petals and see how many there are. And then we have 2 more, the lemniscates. Again, it's lemniscate, kind of an interesting word, but they look like an infinity symbol, or you might think it looks like a sideways 8, something like that. But lemniscates. We'll talk about where all these come from as we move forward. So all of our problems kind of have the same instructions. We're going to graph in the calculator. We'll identify which shape it is, find zeros and maximums, maximum R values, I should say, and then we'll sketch the graph. So here's what I want you to do. I want you to get your calculator out. Yeah, that means yes, get it out. Yeah, sorry, Desmos people, this is you need the 84 here. All right, we're going to hit mode. And we're going to go to instead of a parametric is what I was currently set in, I'm going to change that to polar. That's going to be really important for us. We're going to hit polar. And then you'll notice when you hit y equals, it now says r equals. All right. And I'm going to type in 3 times the sine of theta. And if I hit graph, I can see what that graph looks like. I have a terrible window. So I'm going to hit zoom 6 to kind of get back to a standard window and see what that looks like. Oh, that's much better. Okay, one thing that I notice about this, it's kind of tough to tell exactly what shape I'm looking at, because is that a circle or an ellipse? So I'm going to zoom square that thing. I want to see it a little bit better, and I might even zoom in just a bit. You guys can do the same thing if you'd like. It is a circle, I can tell now, but if the window settings I had made it maybe a little iffy to be able to see it very well. And so we can tell it's definitely a circle. All right, so we have some other questions to answer. And oh yeah, some of you may have said, well, Mr. Hale, that circle wasn't one of the options that we saw on that first slide. You'd be correct, but that doesn't mean that we can't still have other things that we've known for many moons. So this is one of those, so it's still there. All right, now the follow-up questions. Find the zeros and maximum R values. Now when we say zeros, we aren't talking about where it crosses the x-axis. We're talking about where it hits the pole, in other words the origin. And you know what, I see one right there. Now if I hit trace and just kind of follow this around, you can kind of see the pattern that's going on here. At 90 degrees I'm at the top of this circle. I'm going to predict that if I go to 180 I'm going to be back down at the bottom, and sure enough. And if I keep working around, oh look at that, it's 2 laps. And this says to go 0 to 360, does it not? Well, no, it doesn't, but that's typically what we do, is we go 0 degrees to 360 degrees. And so you can see here we've got 0, 180, and 360. Again, it's maybe a bit debatable if we need to include both 0 and 360, but I'll go ahead and do that this time, and then just read instructions in the future and it'll make it clear. Okay, and then the other situation we have is to find the maximum R value. All right, so the maximum R value is kind of an interesting thing. I actually want you to go in and change a setting on your graphing. If you go to second and format, like I've done here, it's this thing above zoom. You see how it has rectangular GC and polar GC? It's okay to have it in either one of these settings, but if I switch it to polar, it makes finding R values much simpler, because basically what it's going to do is instead of giving us points as x comma y, it's going to give them to us as r theta. And essentially what I want to do is find where, okay, here, oh, that's why I'm trying to trace and it wasn't working very well. I was already at 360. I was going the wrong direction. All right, so where do we have a maximum R value? When I watch that R value, I see here at 270 degrees that it's at the top of the circle. That's the furthest distance from the pole. Now it says R is -3, and technically that would still be the same as +3 because it's a radius, so it's fine. And then here at 90 we have another place. So our maximum R values occur, our max is 3, and it occurs at 90 degrees and 270 degrees. So let's take a look at number 2. It's the same kind of question. We're going to obviously run into a new shape though. It says r equals 4 cosine of 2 theta. So I'm going to go ahead and punch that in, 4 cosine of 2 theta, and hit graph. Now I probably want to do zoom 6 because I have kind of a funny, I had zoomed in, remember. Now the only thing you might not like that it's a little bit distorted. So if you hit zoom square, you can get a little bit better view. And that's a beautiful graph, isn't it? Well, what that is, it's a rose curve. This one has 4 petals. All right. Now what we want to look for are patterns as we do this. And one thing I know is that we have the pattern of I have a maximum R value at the end of each of these petals. So I see one right there at 0, and I'm just scrolling through. Ooh, I found a 0. So I'm going to start marking this down. I found a maximum at 0 degrees. I found a 0 at 45 degrees. And as we move ahead, I know we're going to find more of these. By the way, did you notice the max on this one was 4? I didn't actually verbalize that, but it's definitely 4. And I'll go back to my calculator now, and we'll trace around. So we had 45 degrees was a 0, and oh, I went too far. 90 degrees is another place where we have a maximum R value. And if we go to 135, something tells me we're going to find, yep, there it is. We're going to find a 0. And I've made a mistake here, have I not? Yeah, I see what I did. The 0 was 45 and 135. I wrote the max was supposed to be at 0 degrees and 90 degrees. I would guess that you're seeing the pattern already. Like, seems like everything is separated by 90 degrees. So let's see if that continues. Let's go out to I guess 180 would be the next one. And then we could go to 225 and see if that works. Yep, there's a 0. Let's go to 270. We're at another max, 315. And yet we're back at the pole, so another 0, and then 360, we know that's where we started. So we can continue that pattern of adding 90 degrees. You see this happen a lot, where once you find a couple of them, you can kind of just figure out where the next ones are without a ton of work. They kind of work out nicely. All right, let's continue on. But before I continue on, I suppose I should actually answer the question. What is this shape? I said it verbally, I just didn't write it down. It's a rose curve. And this one has 4 petals. Now we can move on to number 3. All right, so again, go ahead and graph it. See if you can find those values. So go ahead and pause the video, graph it, find your zeros, find your max values, and then see if you get the same ones I have. All right, welcome back. So you can see what I've found here. I wanted to show you how can I tell this is a cardioid rather than a limacone, especially when you consider that dimpled limacone, it looks pretty similar. So if you go back to the graphing calculator, I zoomed in right at the pole, And one thing is you can tell, first of all, that this hits exactly on the pole. But also you see how there's a sharp turn where a dimpled limestone, as the name would suggest, is just going to simply kind of bend around that area. So this is a cardioid. The zeros are at 0 degrees and 360. The max R value is 8. That happens at 180 degrees. Let's do number 4 together. So number 4, we can't just punch this in to the calculator exactly as we see it. We need to do just a little bit of work first. What I would do is just take the square root of both sides essentially. So R is going to equal 2 times the square root of the sine of 2 theta. Now technically, yes, there's a plus or minus here. We don't have to worry about that because the plus or minus in polar graphing ends up not being all that important. It just repeats what you already have, so I'm not going to worry about it here. So we're going to do the 2 times the square root of the sine of 2 theta, and let's see what we come up with. All right, now that's pretty small. I can kind of tell what it is, but I'm going to go ahead and zoom in anyway, right at the origin, I suppose. All right, that's close enough. We'll go there and look at what we have here. So you can see that we have a nice, lovely lemniscate. I'm going to drag this graph over here. There's our lemniscate. And when we trace it, what we're looking for are zeros and max R values. Now I can see the 0 right there. There's one at 0. And I'm going to look for max R values. Did you see that? It went from 2. There it is at 45 degrees. That's a maximum value. Its R value is 2. And then as I keep going, when I hit 90 degrees, I'm back to another 0. And then weirdly, the graph kind of disappears for a while. So I need to start writing some of these things down. But you'll notice when we get around to 180, the graph shows back up. Kind of an interesting little thing there. All right, so let's mark down the key information here. We know again that the max value was when R was equal to 4. We had that happen when theta was 45 degrees. I believe there's going to be another place. We'll look at that in just a minute. Zeros, we had them at 0 degrees. We had another one at 90. We just saw another one 180. I bet you know where the next one's going to be. I'm going to go ahead and finish the pattern here, and we'll see if I've done it correctly. And 360 degrees. Oh, and the other thing, I should go ahead and say the name of the shape. This is a lemniscate, just like that. All right, and then like I said, we need to go ahead and find other places where max values occur. And I can see that I've got one coming up here. There it is, 225. Now this is kind of a weird one because the question is, why is this graph disappearing? Like when theta is 300, there's no graph. What's going on? Well, here's the situation. If you look, we have the square root of the sine of 2 theta, and there are places where the sine of an angle would be negative, of course, and you know you can't take the square root of a negative, so therefore it's not going to exist. So it's kind of weird. It just disappears for a while, pops right back. But again, we're just looking for max values. We have 2 of them, and we're looking for zeros, and you see those there. And I wrote the wrong max value, didn't I? The max value is definitely not 4. The max value is definitely 2. I don't know why I wrote 4. All right, this is our last slide. Why don't you go ahead and graph number 5. All right, so you can see my graph here. Some of you your graphs may look a little choppy, kind of like this one. Here's what I did to try to clean that up, and this is a bit of a weird step, but it'll really help as we go forward. I do want to go 0 to 360, but because that angle is 7 theta, here's a little trick you can do. Just do, instead of a step of 7.5, do 7.5 divided by 7. It'll make your graph look a whole lot better. So that just has to do with this is 7 times the angle. That cuts down the step. Now, unfortunately, we can't really cut that 360 or we won't get the full shape. But let me go back to the graph, and it graphs a little slower, but it's still pretty fast. And if you want to, if you zoom square that thing, it'll look even better. So there's zoom square, and now you can see what it looks like. All right, so we have a rose curve with exactly 7 petals. All right, so you can see that rose curve, and when I hit trace right away, I see that I have a 0 I'm on the pole at 0 degrees. It looks like we're going to have others. We'll see what happens when we trace. Now, one thing we're looking for here is where exactly is the end of the pedal, because we can assume that's the furthest distance from the pole, which therefore is going to be our maximum R values. So our maxes are when R is equal to 4, and those occur at theta equal to, let's call it 12.9 degrees. We'll just go nearest 10th. And then let's see what happens as we keep working our way around the rose petal. We'll find another 0 here pretty quickly. There it is right there. Now that's kind of a weird one. It might surprise you that that's in fact a 0, but do you see the R is 2.09, and then look at the end, e to the -9. That's essentially just rounding error. It means 8 zeros and then the 2's, so we're safe. That's a 0. And then as we keep working our way around, let's see if I can get to 4. There it is. I've got 38.6 degrees, and then let's see if we can get another one here. Another 0 would be happening at, oh, I just went past it. There it is. It's about 51.4 degrees. And maybe I could get one more max value. I'm not going to find all 7 of each. Actually, I say that's not even true. There'd be 14 of each in this scenario. It's kind of weird to have one with a 7 theta and have to answer all these follow-up questions. I'm actually not going to finish answering all these. I'm just going to put ... The only thing I haven't done is I haven't said that it's a rose petal, or excuse me, a rose curve with 7 petals. And then, of course, I need to sketch it, and I'm going to be able to make a pretty good sketch of that rose curve by dragging that picture over here. I'd say that's decent artwork myself. So there it is. All right, we have one more. What I want you guys to do, I actually don't think this one's any tougher than the ones we've seen. So I want you to do this one on your own, and then just compare your answers to mine. So pause the video right now. All right, welcome back, and now you can see what I've done on number 6. That's another lemniscate. Kind of looks like the old infinity symbol. You can see where the zeros and the max R values. The max value of 5 occurs as 0 and 180. The only thing about these notes, we didn't see any examples of limaçons when we graphed them. Honestly, I'm not picky about knowing if it's dimpled, convex, or one with an inner loop. I think those will be fairly obvious, but as long as you know what a limaçon looks like, we're good. And I don't think that exploring those shapes is any tougher than any of those that we've seen today. So hey, I hope this makes sense. It's kind of a different topic, but I think it's one that you can definitely handle. So have a spectacular day.